Okay, this video is going to cover some of the basic concepts about motion graphs. And we'll start with the displacement versus time graph. Okay, so here we'll start drawing one out. So you have displacement on your y-axis and time on your x-axis. And let's start with the idea of slope. Slope of this type of graph is equal to velocity. Now, how is this possible? So let's take the slope formula. Delta y over delta x. On our y-axis we have displacement, and we have time on our x. So displacement over time, which you guys should know, is equal to velocity. What this means is that this is the rate at which an object changes its displacement over time. So how fast is it moving? How fast is it changing its displacement over time? And one thing about the slope is that the greater the slope, this translates to a greater velocity. So if we draw another line here to show a greater slope, and we compare the two lines, the pink line is faster, whereas the white line is slower, showing the differences in slope, meaning the differences in speed. Alright, so let's look at some of the other characteristics of slopes. So we'll start with a zero slope. When slope is zero, we have zero change in displacement. When you're not changing your position, you're at rest, and that's what it looks like. The next type of slope we're looking at is a positive slope. So that means it's a positive velocity. You're moving forward and represented as such. Negative slope, on the other hand, is going downward, negative velocity. So that means we're going slower, just means we're moving backwards in direction. And as for the last one, changing slopes, changing velocity, what does a change in velocity mean? It means acceleration. So how does this look like? It's going to look like a curve. And it's represented by this four type of curves, acceleration and deceleration. And you're going to look at the characteristic of the slope, if it's going from slow to fast or fast to slow. So slow slope means flat, and fast slope means steep. So flat to steep, steep to flat. And notice acceleration versus the deceleration curves. And in terms of figuring out if it's positive or negative, you're going to figure out if it's going up or downward. Now we'll move on to the velocity versus time graph, where here the slope is equal to the acceleration. How? Once again, you're going to look into the slope formula, velocity over time. The change in velocity over time is equal to the acceleration. This is the rate at which an object's velocity changes over time. So this is the change in velocity. So essentially, how much faster or slower is this going? And essentially, how fast does not mean the same thing as how much faster. I've seen this misconception. Velocity and acceleration are two different things. So once again, greater slope means greater acceleration. That means it's accelerating or speeding up at a faster rate per second than at, say, a more gradual slope. So zero slope here means zero change in velocity, but this can mean two things: constant velocity or at rest. And here we're going to represent three of them. The one at rest is on the zero line, positive constant velocity is above the zero line, and negative constant velocity is below the zero line. So this just indicates direction of motion. Next is acceleration. Slope is moving away from zero. That means it's increasing its speed away from the zero line. Positive is above, negative is below. They both accelerate away from the zero line. Deceleration, in converse, is the slope is moving towards zero. It's slowing down. Goes from a higher magnitude of speed to a lower magnitude of speed. So if we look at these graphs side by side, we're going to depict the same motion, objects at rest. And then here, we're going to look at positive constant velocity. And then below it is going to be the negative constant velocity. here. Next is a positive acceleration, and right below it is going to be the positive deceleration. Alright, so notice how these two graphs look like. Next is going to be the negative side for acceleration and deceleration. Last thing about the velocity versus time graph is the area under the curve. So here the shaded area under the graph, or between the graph and the zero line, represents the displacement of the object in motion. So how much distance did it travel? You could figure it out by taking the area of those shaded regions. If you look above the graph, that's a positive displacement. Below the graph is negative displacement. And the common shapes that we see in these graphs are either a triangle or a rectangle or square. We represent the area formulas as 1/2 base times height for a triangle, and then for the rectangle square, base times height. And you look in terms of the intervals on the graph, not the boxes. You do not count the number of boxes. And this only happens on a velocity versus time graph once again. So it's important to know, to summarize this, where do we find each quantity based on which graph? The first thing you really need to do is to look at the y-axis. What are we looking at, displacement versus time graph or velocity versus time graph? Because the slopes and the areas under the curve and everything else mean something different. Okay, so this table sort of summarizes each of the 4 quantities on the graphs. And I hope this was helpful for you guys.